Good morning, good afternoon, good evening. Welcome to another video of the Liberian Bitcoin Blockchain and Cryptocurrency Forum. My name is Beyan, and today we're going to be having an awesome conversation. We'll be talking about the blockchain technology. We'll also be talking about cryptocurrencies. We'll be talking about the relationships between blockchain and cryptocurrency, and we will be breaking things down to the ground. I have some very special tech folks here with me. I have Darlington. Darlington was in our video last week, and I also have Nersto. He was also in our conversation last week. These guys are in the tech space. They do some programming work. Ernesto is a data scientist. Um, Darlington, yeah, he's a software engineer. So uh, it's good to have these people when you're having these conversations about blockchain. So, gentlemen, I just want to welcome you. Thank you for coming. And with all due respect, if we can, um, is there anything we want to talk about what's going on in the news in the past week? Anything specific that pops up before we get into our conversation here?
Before the recording started, I was just mentioning that Fed now went live for those in the US. If you live in the UK or India or I think Australia maybe, um, in a lot of Asian countries, this is not news to you. But if you live in the US, this is very news to you and exciting to you, right? Where you get paid, but it takes 2 days before it hits your account, or you connect your bank to something to send money, and then it takes 2 days before it gets to the place it's going. Um, it's because the old system that the US used to use for the banks to talk to each other had a lot of um, human parts, like manual labor. So Fed now is a system that uses the ledger part of blockchain. It uses a distributed ledger system um, that now, because of the ledger technology, we don't have to do a lot of human checking. There's a high level of trust when the banks are talking to each other. So hopefully what that means, if you're sending money, say from Wells Fargo to US Bank, I think those two banks are already participating. As soon as you hit send, within seconds, it will show up in the other person's account. And you don't have to like use Cash App or Venmo or any of those things
Wow.
that used to sit on top of banks. The way Cash App and Venmo works is just because Cash App, they have like thousands of bank accounts everywhere. So if you send me money to somebody, if I send money to someone, Cash App has an account with that person's bank. So then they transfer the money from their bank, from their account to that person's account. That's kind of why Cash App can sort of work almost instantly. Fed now will remove that
So
layer. So
so that
you
would
don't.
that would save a lot
Mm.
of time too, though, when you think
A
about
lot
it.
of time, a lot of fees. Cash App charges a fee to do the instant transfer, right? It's like
Right,
1% or $2 or whatever.
right.
Now you don't have to pay that fee. You can just transfer directly from bank to bank, and it will happen instantly. But like I said, this is new to the US. It's not new to India and Europe and
In Japan, right? Yeah, exactly. That's true. That's interesting. Huh.
50 banks are participating, so hopefully more banks can get on board. Yeah.
That's really good. I hope they're going to be using some of the existing cryptocurrency project right now. Like a lot of people in the
They're
XRP
not gonna do that.
space. You think
They're not
they're going
gonna
to
do that.
create their own pretty much?
Well, maybe we're gonna get into this, right? There's a difference between blockchain and crypto, right? Like
Right,
this is not a crypto thing, it's just using the ledger technology.
right. Interesting,
Yeah.
interesting. Because I was thinking, I was like, with the cryptocurrency space being an open ledger, well, not open ledger, but open source space where the technology is accessible to everyone. It's easy for the government to say, you know what, I'm going to take a little bit of this blockchain technology,
Yeah.
take a little bit of this, take a little bit of that, you know, consolidate everything and create something unique that I want to use.
Yeah, when the government uses blockchain, it's not gonna look anything like Bitcoin or Ripple or Cardano, uh, you know, because
Interesting.
blockchain is I don't know if want to jump into that right
Yeah,
away, but
yeah, we can talk more about this. We'll get more into the content here soon.
well, man, like this sort of leads into it, right? Like
Yes.
blockchain is not like one thing. It's like a this technology that's been iterated on since the 80s that just all comes together and like they
Mm,
call it blockchain, right? And then if you do it in a certain way and put a certain meaning on it, you call it crypto,
right. That's
right?
interesting.
But you see there's like a layer where it's like computers, like at the end of the day, it's computers talking to each other, right? And then you have all this like networking of like trying to get information across physical distances because the computers are not all in the same room, right? So there's that networking layer. And then you have, and that networking layer can be pretty complex, like very complex, right? Because, for example, almost every blockchain assumes that the person they're talking to, the server they're talking to, cannot be trusted,
Right.
or that there is a high degree of chance, there's a high degree that the thing that's sent into that server would never reach. That's where the
Uh,
assumption starts.
and that's where
So
consensus comes to play.
yeah, right. That's where consensus comes in. So how do you guarantee something when you can't trust the person you're talking to and you can't trust that your message will get to them, right? So
Interesting.
so
That,
solving
that's
that problem at a networking layer is like crazy. And that has nothing to do with crypto. That can be applied to all sorts of communications, phone calls, and all sorts of other things, right?
interesting. Interesting.
Um,
You're thinking you're the bigger picture, man. I'm just looking at, I'm being very myopic, but thanks for clarifying that. And that's still anything in the news that you came across this past week that you might want to share?
I mean, pretty much, I saw something about FedNow too, the same information that Darlington just mentioned.
Right.
That's one of the things I was looking forward to is like, how to use it. Like, is it going to be available to applications? Like there's an API or something like that, or are they just dealing with the banking level for now, or is it now open to to any application to use it? And what impact would this have on stable coins? You know, because now
mm,
when you start having US dollars being transferred that easily, with fees reduction, then people would lean towards it more than going towards something that you still have to pay some fees. In the
Right.
blockchain, you have to pay some fees. So
Absolutely.
that's one of the things I was thinking about it. But pretty much that's it. I just been working on the other things. Yeah,
Yeah, it
too.
seems like one of the things I noticed, I know about the free market. The market will always gravitate towards um, the most economical and the most efficient way of doing things, always. That's just how it is. And that's what this whole space, probably why this whole space is actually growing and developing real fast because there's a lot of projection, there's a lot of anticipation that the utility of this technology, the blockchain technology, can actually solve some of the problems we have in front of us. Anyways, thank you, gentlemen, for just providing
But
us a little bit of details about the news. I was
I
I
want to
was
say
hoping we
something.
can I was hoping we can get into the blockchain uh, topic right now, though, since we're going to be talking about that area for sure. Um, so first, the basic for a lot of folks that probably don't know about this space. We are talking to someone who has no idea what cryptocurrency is, what blockchain technology is. How will we define or make that person understand cryptocurrencies and blockchain technology? What is the difference between those two and how are they related?
right. So that's a loaded question, especially if you're entirely green or brand new to the space. I think sometimes the way I like to think about the blockchain and the problem it's trying to solve, is between the 90s and late, early 20, like 2010, right? Information, digital information just exploded. A lot of information got digitized. Um, and I think people used to call it the information age, right? Well, it's just so happen that some of this information have gotten to the point where it has value. Like people put real value on it. Say you've been playing a video game. If you're older, it might not relate to you, but if you're younger, right, you might like buy a skin or like buy something in the game or buy a certain like character and then play that character for years and years to where that character or that skin becomes very coveted by a lot of other people and it becomes like this bragging thing, right? Um, or even banks. How many people carry cash anymore, right? A lot of
Right?
things is just on your phone, beep pump, money is flowing around. You're not moving physical money, and all that is information, right? So
Right.
just that information has value. In some cases, a video game skin that somebody on eBay might be willing to give you 5,000, 6,000, 10,000 even. I've seen some video game stuff sell for. And then in other cases, just sending $5 with Cash App. Um, but even with all that information being more valuable, the problem we started running into is trust, right? Like making sure someone can come in and like hack the system and steal your skin, or the game company can just shut down and shut their servers down, then all that information goes away, right? So just that trust of like, okay, all this digital information is having more value. How do we protect it? I think maybe 2 years ago, like almost every month you heard ransomware, the hospital wasn't working, because someone froze all the data,
Yes.
and
I remember
requested
that.
money, right? So even those information, right, can be hacked because they're all sitting in one place and are vulnerable to attack. So if you go there and you can successfully penetrate that system and compromise that information, you sort of gain power because someone values that information. Millions of dollars was spent.
So
Um,
blockchain technically decentralizes
so
information,
yeah,
right?
pretty much is trying to take that information and remove it and remove the responsibility of one person having to be responsible for it.
Right.
So instead of having one person responsible for keeping this information and protecting it and making sure it's accurate, blockchain wants to say, okay, how can we get 1,000 people to do the job of one person in a way that's not confusing, that's not noisy? So it's a really hard problem to solve, right? Instead
Right.
of one person doing it, how can we get 1,000 people to do it the same job together at the same time? So then instead of a bad person having to hack one person, they have to hack all 1,000 people who might be spread across the entire globe, right?
Which is
Because if you hack,
technically impossible to do that, isn't it?
it's very expensive. It's
Ah,
incredibly expensive to the point that it becomes cost prohibitive. So maybe the thing you're trying to hack is worth 20 million, but it's going to take 40 million to get the job done. So what's the point,
that's not good business then.
No, that's not really good returns.
It's not a good
Um,
business model. Interesting.
uh, yeah. So the way technology makes that happen is basically what blockchain is. It's a lot of cryptography, a lot of networking, a lot of like computers talking to each other and trying to come to a consensus on some things.
Right.
A lot of different technology put together that makes up what people call blockchain,
And then how
basically.
does cryptocurrency fit into that picture of the whole concept of minting a crypto coin on the blockchain and making it pretty much uh, interactive with the blockchain itself?
Right.
And that,
So crypto is one type of information that has value. In this case, crypto is basically just a way to record that someone has the the right to spend a certain amount. They have the right to use up a certain amount of value, right? So just like the way when you go to your bank and you go to like do a wire transfer, right? You don't have anything physical with you, but your company has deposited money into your account somehow. You have no idea how that happens. You just show them your driver license and they type on your computer, and then somehow money leaves your account and it goes to someone in Timbuktu or the UK or Asia or wherever you're sending money to, right?
Right.
So crypto removes the bank. Instead of having to go to the bank and show your ID, instead you can just present this very long password,
Right.
which is the equivalent of your ID. Is typically 12 or 15 words. If you can present this long password, then the whole system can see, okay, what things in the system, in the records that's associated with this password that I was just presented, so the system can know what you are allowed to spend, right?
So
Um,
that pretty much that uh, private key give you access to the movement of whatever information you're trying
right.
to move on the blockchain.
Right. In this case, is so crypto then takes that information and associate some monetary value to it, right? Um,
Absolutely. Interesting.
right.
Interesting. And Nestor, you want to add to that? The relationship between cryptocurrencies and blockchain technology and
So when it comes to blockchain technology, basically, it's centralization versus decentralization. That's why blockchain came in. And you're trying to solve a problem, right? So before blockchain, we had centralized databases. So you have a server that feed any request from anywhere, and then you have people sending requests and they send a feedback with the data or whatever. But then that server can be compromised. You have people tampering with it, the administrators, or even like a hacking situation. So what blockchain is, the blockchain created a new way of us, decentralizing the data that is on the server. So the vulnerability of the data is reduced. Whenever is not at one location. So if that one location is tampered with, you have a copy of it to another location. So before you can basically hack the system or defraud the system, you will have to basically find all the copies of that blockchain and um, and try to change the information that's in all the systems. And you can have thousands of copies, you can have millions of copies. It depends on the amount of people who participate in the network and have a
right.
copy of the blockchain. So
Absolutely.
what a blockchain is essentially is blocks, right? One block is information, data, right? So now how do you link that block to the next block to the next block is what we call blockchain. Think about it like a book, right? Or and versus one page. So let's say we have one page and we write all our information on that one page. Versus we have a book, so every page we put information, and the next page two, we put the next information. So each page is a block, right? So now what link page one to page two is the number, right? Page one and page two, the next block, and page three, the next block. Now, how do we know that somebody didn't go and change information in page two? Is because of the hashes, which is called crypto. Cryptography is the ability for you to hash information. What hashing does is, for example, right, you can have a whole data of information, and you can get that entire data down to one number or one a string of value called hash. And that string of value, when you decode it, it will give you the same it will give you the same information that you actually use to create that string of value. So it's like a magic. You cannot you can only recreate the thing that created that value. It cannot create something else. So that's why they call it cryptography. So what they do is that one block, they merge all the data into one value called the hash value, right? That hash value, if you interpret it, will give you the same data that was in that block, right?
Interesting.
Right. So that one hash value represents the data that is in that block. If you tamper with the data, it won't produce the same hash value anymore. It will produce a
Ah,
different hash value, right? One tamper with it will change everything. So now, how do page two knows that page one is correct? When you're creating page two, you have to reference the hash value. That's what they call it, cryptography. Cryptography is when you hashing stuff, when you, let's say, you think about the word compress. You compress
yes.
all the information into one value. That is a cryptography. Now, page two have to have that. So you have to say previous block hash. I mean, the previous page one, page two got to reference it. So if I'm looking at page two, I should know how to recreate page one just by that one value or hash that is on page two.
So
So
page two is pretty much connected to page one, and page three is connected to page two, which
page
is
two,
connected to page one. And page four is
they,
connected to page three, which
right,
is connected to two, which is connected to one. So
one,
in order to get rid of anything within that block, you have to technically change the whole chain, which is almost
the entire
impossible.
chain. So if the chain is 1 million blocks, you got to change everything in there to be able to wrap this. And because one tempering, one information change, the hash
Right.
is different. So
Interesting.
it's a lot of things that goes in it. There's nuances also that participate in it. Whenever we
Right.
talk about consensus, how do a node reach let's say a proof of work consensus, right?
Right.
How do a person validate the transaction or mine the transaction or be chosen as a miner? You have to go through a puzzle, right? And that puzzle is basically trying to guess the hash value, right? And to guess the hash value, you can get to it. Is that you gotta try different numbers. We call it nuances to arrive to
And
that.
that's where the computational capacity demand come from, right?
Right, right. So
Yeah.
those nuances, you got to keep changing them every second. So you don't know how many billions of them, or maybe millions of nuances. Nuances just numbers. You changing until that number you get it, and it's the boom, you get it hash. Then that's when it chooses you. If you're the first person that arrive at the correct information, that you are chosen to validate. Because the assumption is, if you can go through all those nuances to arrive at the correct one, that means that you, most likely, is not a fraudulent person. You actually did doing the work and you
Yeah.
actually arrived at the right answer. So
Proof of
that's
work,
how they are.
technically.
Proof of work.
So
Yeah.
Interesting.
what we're getting into here, kind of getting into the next point of like how can it enable security? How can it be secure?
Right.
And also transparent at the same time, right? So going back to the picture of right now, if you want to transact using currency that your country makes, like your country money, right? You go to a bank and they have vaults and security person and cameras, and the government will come after you if you rob a bank, right? So that's how banks have security. But if we're going to get rid of the bank, then how do we protect the information, right? Like, how do we prevent someone from taking the stuff you have in the system and saying it's theirs, right? And how do we protect that information? So you don't have banks, you don't have ID cards. All you have is the cryptography, right? And that cryptography, you don't have to really understand how it works. Is basically lots of math, but for us humans, it tends to be represented as a set of 12 words. So whenever you get into blockchain, they will talk about seed phrase and passphrase and key, and typically it's just these 15 words you get, right? And that has cryptography built into it and is part of the security system, right? So even though everything is being recorded, because everything is being recorded by thousands, sometimes 3,000, 4,000 different like people like myself running these servers all over the world, that also means everything has to be done in the public, right? Like the blockchain is just a database to put stuff in. Crypto is one kind of stuff you can put on the blockchain database. And that's where Interesting was talking about the blocks and putting everything together, right?
Right.
That's just how the database is built, right?
You know, I
Um,
was thinking about something very interesting here. we just mentioned, I think Ernesto mentioned something about the 51% attack, where in order for the blockchain to be compromised, whoever is actually engaging in the attack has to basically have 51%, basically control 51% of the computational capacity of the blockchain, if I'm right. Now, the question is, let's say you go back to Bitcoin during the Genesis uh, period, where the very first, block was actually processed. Now, is it easier to hike the
Yes,
blockchain during the Genesis than it is as the blockchain actually lives on?
yes, 100%, right? And that's why the longer I live, the harder it becomes to hack, right? Because part of why when I talk about the 51%, that's part of the security. It is secure as long as all these 1,000 people around the world are not able to easily collude with each other and like agree ahead of time what they're going to do. As long as it's hard for them to coordinate what they're going to do, um, it's hard for them to be able to change the information that's on the system. The
Interesting.
part of why we have lots of people running the system is so that everybody have to agree in this automated way. That's where the consensus comes in, and the working and the hash and all that stuff. It's just these people trying to agree. One of the things that's part of that whole system that every blockchain have this is a level of randomness, right? Typically, when somebody needs to add new information to the system, that can only happen one at a time, right? Um, but once they add it, for it to become the root of the land, everybody have to agree on that new information, right? So
Right.
one of the randomness that happens is it's hard to predict who's going to be the one that add the next chunk of information to the system next, right? So you don't have, Chase and JP Morgan doing this stuff anymore, right? It has to be in an automated way, and everybody switches who's going to be the next person to update the history of what's happened for the day or for the hour or for, I think Bitcoin does every 6 minutes, was it 6 or 12? I don't remember. But every so often, these blockchain system will look around and see, okay, what's all the information that's trying to be added to the system? Let's collect it, let's put it together, and then let's add it to the history, right? Who does that job is randomized. So for you to be able to like predict who's going to compromise the system, you have to have a majority share of the control of the information and the agreement, the consensus, right? That's why you need 51%. So if you have 51%, chances are one of your people is going to be the one who gets to write the information, who's going to, give you money you don't have, right? It's kind of like if you knew someone that was working at the bank and you told them to update your balance to say you have money you didn't have. Like that person will go to jail for the rest of their life, right?
Right.
But in the blockchain system, we don't have that kind of level of control who's watching these people. So
Yes.
instead, there's a randomness to it. Or in the case of the Bitcoin, there's this hashing thing, which basically makes it random because you don't know who will be the next person to guess the number next,
And
right?
also
But if you
too,
have
the location of whoever gets the
right,
who
and
gets
so
to
the
be
one
chosen, no one can predict what region they're from until it happens.
and after the chosen, at least the majority of the people have to agree on a new state of things. So if you can predict where it's chosen next, and you can go ahead and add information that shouldn't be there, then you have this next challenge of convincing everybody around the world, or at least 51% of those people, to say this information is correct, right?
Interesting.
That's why you need 51%. Because if so now if you control all these computers around the world, then suddenly you guys can say, oh yeah, that information is correct. This person, is the owner to this new Ferrari over here, right? Or is the owner to this house deed or something, right? Or this
Right.
person has $1 million, right? When they shouldn't. Um, So until everybody agree to this new information that's coming in, it doesn't become, the root of the land. And so that's how blockchain can be secure, right? Because everybody have to agree. Every time you update the system, everybody has to agree to it. And part of what people say is decentralized. When people are verifying that information, they don't need to talk to each other to verify it. Every single system that's on the network has all the rules to be able to verify every piece of information that comes in. So you get 1,000 independent verifications, right? That has to agree on every new piece of information. So you can do everything in the public and it can still be secure because of this like mass agreement that has to happen every single time,
Absolutely.
which is
It
pretty cool.
it
So
seems like
let-
and consensus is part of that whole concept of decentralization too, in
right.
essence. Gentlemen, I think I really like the fact that we're getting into details. We're getting more into the nuances. But just for the sake of time, if we can kind of spend at least 30 seconds on some of these questions, and because we still have a
Okay.
few things to cover.
30
Uh,
seconds.
Let
we
me
have
let
we
me
have
Start the
50
clock.
more minutes for
let me
this.
try to see what I can touch
Sounds
on
good.
51% a little bit too. If that's fine.
Sure. Yes. Yes.
So, just to for some other viewers out there may want to get another perspective. So there are different kinds of consensus. So, as we explain it, so people should understand that, some of the explanation may not be for the consensus that they're familiar with. So they have proof of stake, they have proof of work, and they have proof of authority and all the different things. And they have different ways of validating their blockchain transactions, right? Usually when we're speaking about blockchain in general, we speak more about the proof of work, which is the first kind that was written by Bitcoin starter. So I will speak on that and then a little bit on the proof of stake. So proof of work, you have this puzzle that people got to solve to get this hash. They got to keep turning this wheel of nuances to get this one hash. Now, the person that get the hash, right? Basically, there are other people on the network, right? That also are trying to do the same thing, process the transaction the same way, right? There's millions of people around the world doing the same thing, right? So if I say this transaction is processed and basically is $100 from Beyan to me, that's the transaction approved. I approve it because now I can approve the transaction. If there's 1,000 validators on the network or miners on the network, out of that 1,000, 501 of them should have the same answer as me. If
That's
if
the 51%
that's
right
the
there.
51% right there.
Right.
If I arrive at an answer saying that Beyan sent $100 to me, 51% of everybody who validated the transaction and network should also have the same answer. If it's not the case, that means that my validation is invalid, right? If it's the case that everybody, like 51% of the people who validated the transaction agree, then it's valid. Then it becomes added, or you say committed to the database. That means now everybody on the network will receive a copy of that confirmation saying that now we have agreed that this is correct. So that's how it works on a proof of work system. Now,
Interesting.
when it comes to proof of stake is basically people who are chosen to validate. They don't have to do any complication to like go through all the nuances to find the hash value. They don't do that. They are people who they are recognized to be, whichever way they choose them to validate the transaction. Sometimes they are 100 or 200 or 500. Now, they too will have to go through similar process, majority carry the rule, right? In that situation. So if you have majority that agree that this transaction is valid, then everybody agrees and that transaction become appended to the blockchain. So that's how it works for 51% attack. Because if I have 51% of the node on the blockchain, that means that if I say this, everybody who agree with me probably will collide it, right? If only 100 people on the network, I only need 50 people, 51 people to agree with me. to change something. So the less people you have on the network, the more vulnerable the network is for 51% to happen, because I just need to convince the people or hack into the computers.
Right.
But for me to hack into 1 million computers is more difficult than to hack into 10 computers, you know? So that's the reason why 51% is better with proof of work. Proof of work, and when you have more validators or miners, is much better to protect it from 51%.
Okay, nice.
Let's do the rapid round.
Let's do,
yeah.
Right.
There's a lot of topics in the sheet here, but
30 seconds, guys. 30 seconds.
yeah, there's a lot of buzzword. I think if we did a rapid round, it will at least give people something to start, other words to start looking
now
up.
one of the things that a lot of folks actually who don't know a lot about the space but often heard a lot of terminologies like private key and public keys. Some of those people have bank accounts and they understand how that operate with the bank process. Now, how does the private and public key relate to like the legacy system of a bank account process?
If I can do this in 30 seconds. So the public-private key, right? Because you don't have anybody to say, hey, this social security number goes to this account number and they have this value, right? In blockchain, you get two keys, one's public, one's private. Whenever you are giving something on the system or whenever someone is recording something for you, they stamp that thing with your public key. So then every time you want to interact with that thing, you have to prove that you have the private key to that thing that has your public key stamped on it.
So the private key give you access to whatever information you're trying to obtain from that.
Yeah, it proves that you own that information, that you are the owner of it. You have to present it. So your public key has to match the private key that's associated with that thing.
It could be, it proves that the person has access right to it. They might not be the owner. Like in some cases, maybe let's say multi-signature account we talked about last week, where 4 or 5 people have access to a certain account or a certain wallet.
Yeah, like an authorization, right? It's a way to authorize that you can do the thing you're trying to do.
Or your signature from a banking perspective. You have signature right on that account. Interesting. And another thing that also came to my attention when we were talking about the concept of validating a block, after being granted the right to do so. Incentivization is one of the things that comes in place. How does this system, the blockchain, actually incentivizes folks to actually validate the transaction on the blockchain and secure the network? How is that process?
Ernesto take this one.
Ernesto.
Yeah, so because it's now a bank and we don't have salaries for people to work on, it's mostly open source, so people can work. It's not, this one is psychology now. People will voluntarily work for something if they're getting something in return that can help them financially to take care of themselves. So what the blockchain system does in case of proof of work is they whenever you actually process a transaction, right, like a teller in the bank, right, you get a salary, or we call it compensation, which is like an incentive from that block. It gives you a block reward, right? And that reward basically you can use is actually you can transfer it to like a fiat currency. If it's Bitcoin to fiat currency, you can use it as US dollars. If in the case of proof of stake, same thing. Transaction fees. People pay transaction fees whenever they send a transaction. So that transaction fees is being used to pay the validator who validated the transaction. So that's how they get paid, and then that money is basically the system paying them. So it's not like an institution paying them. It encourages them to like use their computers, their servers, and their time.
So the idea of incentivization within the network is very important because it technically it's kind of like the life of the network, technically. So my question now is, in the case of Bitcoin and other very prominent proof of work system, And we can answer this in 15 seconds, 30 seconds here. What happens if we don't have miners for Bitcoin? How would let's say the mining of Bitcoin becomes very, 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 very expensive to do because of the electrical uh, capacity and energy consumption of proof of work. And the miners in some capacity cannot afford that process anymore. What happens? Does the networks, does the blockchain still survive? Does the Bitcoin blockchain still survive? And if
Absolutely
it
not.
does, what keeps it going if we don't have the
Oh,
No,
miners?
absolutely not. How can you, it depends on the miners are not people. They are computers. So when you hear the word miner, you may think that is a person, right? It's really not a person, it's a node. A node is a computer or a group of computers, right? So a company which can be 10,000 people can own a computer, which is a miner, right? So the computers are processing the transaction. If they don't exist, then there's no network. You get my point, right? So every computer the computer is the one receiving the payment, actually. So the person who owns the computer gets the payment. So if it's a company that owns a computer, then the company gets the payment. If it's an individual, then he gets the payment. So
Because
without the computer, there's no network.
one of the
I,
things,
I have another take on this, Ben.
sure, sure.
So the proof of work, all it's doing is a way to introduce randomness as a security mechanism. We don't have to do that forever. Blockchain is just software that can be upgraded and that can change, right? So if we got to the point where it became too expensive, we will come up with a different way to do randomness that is not as
Interesting.
expensive.
Because I'm thinking, the way Bitcoin is actually um, programmed by Satoshi, obviously, as those halving goes on every 4 years, the supply is cut and it becomes more expensive to actually mine a Bitcoin. Now, the question will be, obviously, the last Bitcoin will be mined in 2140, around that time. And when you think about how much it would cost to actually mine that Bitcoin, the very last piece of Bitcoin, be very expensive. So my question is still, are we going to technically adapt to maybe new forms of energy and cheaper forms of energy before then that would make it even possible for the miners to be able to afford that process? you know, you know what I
Maybe,
mean?
but again, we're focusing on that specific. We're focusing on what on how we're trying to achieve the thing versus what we're trying to achieve, right? The only reason why we have mining, we have the electricity, that is a feature to make sure so you can easily predict who's going to be the next person that's picked.
Right.
Right. So Cardano is a blockchain that works exactly like Bitcoin, but it doesn't use as guessing to decide who's gonna pick next. That is picked within the system itself using like a verifiable random function, right? So maybe 20 years from now, people can see that, okay, this also hasn't been hacked. It's been running for 20 years, nobody's hacked it, we can trust it. And so potentially Bitcoin could adopt something similar.
Absolutely, absolutely. Gentlemen, I think we at the top of our hour here. This is a conversation that never ends. I tell you this, sometimes we had an agenda to sort of follow here and complete a whole lot of items, but the concept of blockchain it can be a little bit complicated. Um, and sometimes, if you want the audience to really understand these concepts, you have to kind of take your time and you have to go a little bit slower. I hope we didn't really say anything that kind of went over your head. Um, just stay in there, be patient. This whole concept, one day you will kind of be able to break it down. We do the best we can every Sunday to be having these lectures and posting these lectures online just to make sure you have access to them. We went over so many things today. We talked about the difference between cryptocurrencies and blockchain technology. We also talked about the utility of blockchain technology and how it works. We talked about centralization and decentralization. We talked a little bit about the 51% attack and what makes blockchain actually solid. We talk about a lot of other things. I hope you pick up one or two things from this conversation today. And before we close here, I would like to ask our guests if it's something that they want to kind of touch base on before we lock in. So Darlington, is there anything we're missing out here that you think is it might be important for our audience to pick up?
Just start, I think if you're going to be following these conversations, then maybe over the course of the week, just read about specifically distributed ledger and blockchain. Don't even think about crypto yet. Just try to Google some of that stuff and read about it. And then when we cover other things and we cover more crypto and NFTs and tokens and DEXs and oracles and DAOs and all the things you can build on top of blockchain, the more we talk about different things, the more it will make sense. If you understand, if you sort of get a good grasp of distributed ledger and like blockchain itself. So I encourage you
Absolutely.
to look up stuff on that.
Absolutely. Definitely. There's a whole lot to talk about, man. This is so many things to talk about in this space. Ernesto, is there anything you think you might want to touch base on before we close up here? I know we talked about so many different things.
I mean, for those who watching, I would say I think next week Saturday or Sunday, right? Supposed to be on the show on the show, right? For an interview, right? For bracket, I believe so. Right, Beyan?
Yes, yes. Next week.
Yes. So those who watching, if you want to hear or get more insight about how a blockchain application can be actually utilized like a social network, wallet, how to like use transact, send tokens from one account to another, how the new word of economic digital economy is about it's going to be working. So we'll be discussing bracket, which is a social network slash digital economy for the culture in a sense. So that's why I'll be discussing this Saturday. I will be doing a demo too with Beyan. So those who will want to be there, it will be very interesting to come, and then you can ask questions and also, just listen on. Yeah, that's what I want to say.
Absolutely. Thank you so much, Ernesto. People, this is it. We're going to be here every Sunday. We are very, very focused on making sure that the information of blockchain technology and the utility of blockchain technology and the implementation of these technology into our lives, we want to share that with you and potentially actually motivate you to start doing your own research and start looking into these technology. Because in this world, people, money is not power, information is. So thank you so much for coming, and we'll see you next time. Bye-bye.